Engineering the Brain, presented by
Connor Beisler,
Ethan Elsler,
Francis Leary,
and Keegan Gentry.
The brain is one of the most complex organs in the human body. It is extremely vital for our day-to-day lives. It is responsible for carrying out seemingly simple tasks, like breathing, to more complex tasks, such as contemplating calculus at 8 a.m. The brain has mystified people for centuries, dating back to the Egyptian times. Recently, there has been a major push for further comprehensive understanding of the inner workings of the brain. The government is interested in funding such brain mapping research. Reverse engineering can also be referred to as back engineering. It is the process of getting information or design inspiration from a machine or man-made item. This can often involve taking apart the item to see how it works and analyzing the components. So, reverse engineering can be classified as taking the brain apart to understand how it works. However, taking apart a living brain is pretty controversial and inefficient in practice. Therefore, technologies can be used to further explore the mechanics of the brain.
Reverse engineering the brain can lead to further innovations in several different fields. By understanding how the brain works, engineers can build smarter computers, robots, and systems. These new forms of technology can improve our way of life in all aspects. Another benefit from researching the brain can be new discoveries in the medical field. By learning how neurons fire and why they die, researchers can establish why and how the myelin sheath surrounding the nerve axon breaks down and causes Alzheimer's disease. Understanding the reasons the brain malfunctions can help us cure neurological diseases.
Current neurological research techniques can help us understand how to reverse engineer the brain. Brain mapping and even more specifically neuroimaging can help scientists get a closer look at the anatomy of the brain. Other types of brain imaging, such as brain activity mapping, can help us understand which parts of the brain are active and inactive during certain tasks. We can further research the brain by developing new technologies of scientific discovery.
Creating new technologies to treat neurological and genetic diseases can cause controversy. To develop these technologies, it will be costly, and the question of funding will come up. Along with this, the moral implications are bound to cause ethical disputes among many different groups. The future of brain research is bright. It is an extremely prevalent issue in scientific communities. Advances could include technologies such as more advanced brain-to-limb prosthetics, Alzheimer's and Parkinson's disease treatments, mind mapping, and more advanced personality testing.